Test Script Processor, or TSP, is both a command set and a programming language. But what does that mean for a programmer using TSP? To control an instrument with code, the instrument's settings and capabilities must be mapped to a set of code commands. When the instrument receives a command, it executes the requested operation. Each TSP-enabled instrument has a set of commands that cover the entire range of functionality for that instrument. In addition to operating like a traditional command set, TSP is also a programming language based on a lightweight embedded scripting language called Lua. This offers two important benefits for instrument control. The commands themselves mimic high-level languages like C# or Python, and the instruments are capable of executing simple programming structures like for and while loops outside of the instrument-specific command set. TSP commands can be split into two categories, attributes and functions. These follow the same definitions as most programming languages, where attributes are a setting or a value, and functions perform an action. The TSP command syntax uses a tree structure. At the base of the tree, you have large subsystems of the instrument, such as the buffer, the instrument source, and the trigger engine. Each of these subsystems then branches into smaller subsystems. For example, if we follow the trigger branch, we may want to work with the trigger model, digital I/O triggers, or external triggers. This branching continues until we reach the feature or operation we are trying to use. Let's take a look at this in action. Here we are in Test Script Builder, a platform to develop TSP. We have connected a DMM 6500 6.5-digit digital multimeter to the PC. I want to take a single measurement and then judge if that measurement is above or below a limit value. We'll start by resetting the instrument. This ensures that all settings are at default. The first setting is the DMM measure function, which we will select to be the 2-wire ohms function. The measure function is an attribute, so we treat it as such. Next, we'll configure a few of the DMM measure settings using additional attributes. Because these are measure settings, we will use the same structure, dmm.measure, and then the setting. We'll set the NPLC, the measure count, and the measure range. Now we can acquire a reading. We are only taking one reading, and we are not using the trigger model, so we can use the dmm.measure.read function, which returns the reading to our variable. Once we have the reading, we can compare it to our threshold. In this case, we want to know if the resistor is above or below 10 kiloohms. We can use an if-then-else statement to judge the reading and change the display accordingly. The structure is closed with an end statement according to Lua syntax. Finally, we will tell the DMM to display the user swipe screen so that we can review the result on the front panel. For more information on how to empower your instruments with TSP, please visit our website at tek.com/TSP.